Welcome back, my calculus doing friends. Today we're going to look at 1.2, and so let's get to it. So 1.2 is has a lot of graphing in it, and it talks about the essential functions. And if you're wondering, well, what are the essential functions? There are actually quite a few of those essential functions you would have learned in a math analysis class or pre-calculus class, like y equals sine of x, or y equals cosine of x, or y equals tangent of x, y equals the absolute value of x, y equals x squared. This one's a circle. I guess they mean equals some radius, right? Squared. And y equals the square root of x, and y equals 1 over x. So they have quite a few of them here listed in this little dance move joke. And this is question 4, and it's asking us just to match. And so we're hoping that from your graphing that you did in an algebra course, that you would recognize that, hey, that's going to make a line. And so I could go in here and I could look for a line. And so it looks like G is a line. So this is G. And then on this, that's the exponential function. And I'm hoping that you know that, hey, the exponential function has this kind of a look through it, about it. Right, so that's what the exponential function would look like. If depending on the base that you have, if your base is bigger than 1, then it's going to look like that. Whereas if your base is smaller than 1, so this is y equals b to the x, where b is greater than 1, and then I'll erase that and move it over a little, and if it looks like this, this is y equals b to the x, where b is between 0 and 1, okay, is how it would kind of look. And so since this is greater than 1, we're looking for something like that, right? So this must be F. And then y equals x to the third is snake, right? So we're looking for a snake. And then they also have the cube root of x, which is also a little bit of snaky as well. So I have kind of left this one that I'm tracing out, and this one that I'm tracing out. I'm thinking about making myself some chocolate chip cookies after this video, and sounding kind of good. I don't know why matching graphs was reminding me of that. If you didn't know, you could pick some points and just kind of pick some points on this just to kind of see. But if you've been working with them in Math 1, well, that's what they had you do in order to learn it. You probably realize that this one is y equals x to the third. And so this is not really, it's just testing whether or not I know that. It's not, I really didn't figure these out. I really already knew what the shape of those were. They kind of do quite a bit in the book with, if you look at textbook homework, about having you graph some of them, matching and graphing them, just to see if you remember those shapes that you learned in Math 1. So this is question 7 out of your book. It says, find an equation for the family of linear functions with slope of 2 and sketch several members of the family. So they're wanting us to draw some linear functions. That means it's a line with slope of 2. And so I'm going to draw one on here. And so if it had this point on it, I just picked that as a random. So if you're thinking, how did you pick that point? It was random. And slope of 2 slope needs to be written as a fraction in order to use it, where the numerator is the rise and the denominator is the run. And so from this random point that I picked on here, I would go over 1 and up 2, and that would be another point on the line. And 2 points determine a line, so there I've got, and I did find my ruler, and I can draw in that line right there. So there I sketched one member of the family with slope 2. And it said several members of the family for me to sketch, so I could pick another random point. And I could pick this point, but well, I'm picking it right directly in the center, as crazy as that sound, but over 1, up 2, right? And so it is a sketch after all. And so I was about to say that I would probably prefer to pick points that were on corners, but then I decided, well, what the heck, whatever. The first point is random. Pick it wherever you want, and but since you're going to use the over 1 up 2 to find another, I was taught to count the run first, so that's why I always say over 1 and then up 2. But if you were taught to count the rise first, you might be saying, well, I thought it was up 2 and then over 1. And the good news is it doesn't matter. So if I've done a real good job at these should look parallel. And on my paper, they look a little more parallel than they do on the screen to me. Maybe it's because of the angle. I'm not sure. Anyway, but they also asked me to find the equation of this family of linear functions. And so I was kind of thinking about, well, if I'm thinking about an equation, I have some equation builders. And so this is one of the equation builders, y equals mx plus b. And here's another equation builder, y minus y1 equals m times x minus x1. That's another equation builder. And so I know the slope, it's 2, and that's this. And b is the y-intercept, and that could be any value. And now, coincidentally, for this value here, this graph here, it looks like it's going to be up there, the y-intercept, somewhere. This is, if I count up here, this is 7. And so maybe 8 or 8.5, I'm not sure. I don't even care, right? Because just draw a random one. And this one looks like it has a y-intercept of somewhere around -1, -2, -3.1, or something along those lines, right? And the y-intercept is going to vary for all of the lines that I would draw. So if I draw another line on here that's not the same as these two lines, the y-intercept is going to vary. So I'm going to leave it as b, and it could change, but the slope needs to be 2, and y and x are part of the equation of the line. So y equals 2x plus b is the equation of both of those lines. And I could draw another one, and it would also be the equation of that line. So where b doesn't have to be an integer, b is any real number, and so doesn't even have to be a nice number. It could be pi. Pi's right here for b. 1, 2, 3. Pi's 3.14. So somewhere around here would be pi being b, right? And so, anyway. Okay, so the next question here says, find the equation for the family of linear functions such that f at 2 equals 1. And what they're giving you when they say f at 2 equals 1, this is an ordered pair. So they're just giving you a point, and that point is x is 2 and y is 1. So that's what they're giving you, and they want me to sketch several members of this family. So we were sketching all things with slope 2 over here, and we're sketching over here all things that go through 0.21. And so there's 0.21, and it can have any slope. So it can have, I didn't even figure out the slope on that, right? I just drew a line through there, and we could figure out the slope on that if you liked. It could be like this, right? It just has to go through that point. And they're wanting us to state the equation for that. And if I go back to my equation builders, this is 2 equation builders, and I actually have more equation builders than 2. I actually have for horizontal line, y equals a number, and a lot of books use b for that number, and x equals a number, and a lot of books use a for that number. I'm just calling them that. And this is a horizontal line, and this is a vertical line. And I almost drew a horizontal line right here, but this one's definitely not horizontal. Vertical line. I don't know what I was saying. And here's, I'll draw a horizontal line one in here too. So they want me to come up with an equation of that family. And so the slope is the thing that's unknown, right? The slope can change. And so I don't want to put anything in for slope. And so this equation right here is the y-intercept. Is it changing? And the slope is changing, the y-intercept is changing. And so this equation doesn't seem very helpful. But this equation over here, the x1, y1 stands for a point. X1, y1 stands for a point on the line. And we have that point, 2, 1, right? So y minus y1, which is 1, equals, the slope can be anything, and then x minus 2. And if you liked, you could rearrange that. I'm not sure what they did in the back of the book, and I intended to look, and I said that yesterday too about another. The good news is if you like, you can look, and check it out. You could also add the 1 to the other side and make it look like this: y equals m times x minus 2, and then I can add 1 and add 1 over here, right, and have that. If you liked. If you say, well, I really wish that you would distribute the m, and certainly that would work. Now I wanted to make sure that is this picking up this vertical line, and what kind of slope does a vertical line have? Yeah, the slope of a vertical line is undefined. And so this equation right here picks up all of the lines, I think, because slope is 0 would be fine, right? And we would get y equals 1 as our equation, and that'd be okay. And a slope of 2 would be fine. And if you, I don't have a slope of 2 drawn on here, but you could put in that, and that would be the equation of the line. That'd be perfect. But I think the one that's leaving out is a vertical line, and it didn't say anything about that. So I think that this gets, the majority of the lines, but I think I also need the equation of the vertical line. So I think I also need to say, if I want to get them all, and the equation of this vertical line is x equals 2, right? X equals a number. And so what is x at every point? What is the value for x at every point on this line? Well, it's x equals 2. So I think now I can get every single line. I don't think I had to do that over here. I don't think I had to worry about leaving any out, because b could be any real number and that got any, but I think that I did leave out. So this gets all of the lines that are horizontal and all of the lines that are slanted, even downhill slanted. So I'll draw a downhill slanted one like this, right, on there. And then this one gets the vertical one, because m being undefined would not make sense. You can't put in undefined in your equation there. Okay, and then they want to know which function belongs to both families. And so what it's going to have in order to belong to both families is it's going to have a slope of 2, and it's going to have to go through the point 2, 1, right? Those are the two conditions. Here it had a slope of 2, and here it's going to have go through the point 2, 1. And I can use whatever equation builder I want. I'm going to choose to use this one is what I'm going to choose to use. So I'm going to put in here y minus y1 equals, so whatever equation builder I wanted to use. The other one would work as well. You would use the information you have to find b. Minus 1 equals 2 times x minus, I did that right. Yeah, I'm okay. Right, because this is x1, y1. I got thinking about those cookies, and then all of a sudden I was thinking, am I putting this in right? So this is going to be over here 2x minus 4, and then I'm going to add 1 to both sides, and I'm going to get y equals 2x minus 3. And that would be on, it could be on both graphs, right? And so here, 1, 2, I almost drew that one. I just coincidentally, I mean that, because it's almost going through there. It's not quite. You're like, oh, don't worry about it. But I wanted to draw it. So over here, and now I'll have it perfectly. So here's the line we're discussing. Oops. And you can see that it has slope 2. And then over here, when I put that on here, 1, 2, 3, over 1, up 2, over 1, up 2. And you can see that it goes through that point as well. So it does both. It does both things. And so that's what they were asking about. Okay, we did a lovely job on that. I was stalling because this one is hard. So it says find the expression for the quadratic function whose graphs are shown, and so we'll start with this one, and then we'll give a try to that one, and we'll see how we do. And so on that quadratic equation right there, I seem to have the vertex being there at 3, 0, right? So right there is the vertex at 3, 0. And so just like when we were finding the equation of a line, we needed some builders, right? So these were to help us build the equation of a line if we were coming up with it. Well, if you're building a quadratic function, there are some quadratic builders, and those quadratic builders are this. Y equals a times x minus h, quantity squared, plus k. And what the h stands for is the x coordinate of the vertex, and what the k stands for is the y coordinate of the vertex. And then the other one is, this is in standard form, y equals ax squared plus bx plus c. And if you're talking about the same quadratic function, the a should be the same in these two. And so if I was trying to, I don't know the a for this one, right? I know the vertex, but I don't know what a is. But it should be the same value for a if I was using that one. And I know this doesn't have b and c in it. And so anyway, okay, so this is what this would look like using this one here. Y equals, right, a, and then x minus, and then h, right, is 3 squared, plus k, which is 0. So this would be y equals a x minus 3 squared, right? And I need to find the value of a, and I haven't used all the information that they gave me. And so I hope that you're thinking, how can I find the value of a? A is a constant, where x and y are not constant, but I can use a particular value for x and y, which I'm given right here, to find out what a is, because a is constant for this parabola. So I can put in for x, right? X represents infinitely many values. For this point, x represents 4. And for this point, x represents 3. And for this point up here, you know, x is representing, I don't know, I'm kind of eyeballing it, 6 or so, right? whatever the value is, doesn't matter there, but it's a different value of x. And so I'm going to be able to use that value for x and this value for y to find the constant value a. So y equals a times x, which is 3 minus 3, 4, right? I should have been using, I was getting it to wipe out and there would be no value of a, and I'm like, what in the heck have I done wrong? And what I did wrong, my eraser's not erasing it, what I did wrong is I looked here and used that for my x value, but I don't want to do that. I want to use this value for my x value, 4 minus 3 quantity squared. So this is 2 equals a times 1. That's pretty convenient. So 2 equals a. So the equation here is y equals 2 times x minus 3 quantity squared. So that's the equation of that parabola. And so, and if you'd like, you could go and use Desmos or your graphing calculator or whatever, and you could graph it and you could make sure that, hey, does this parabola indeed look like the parabola that they're giving me there on the screen? Does it have a vertex of 3, 0, and does it go through the point 4, 2, and have the basic shape of f as given? And you'll see that, you know, hot diggity dog, it does. I had a graphing calculator, and I think it might be at school, and so maybe someday I'll go over there and see if I can get it. And so this formula is very helpful for building the equation of the parabola if you know the vertex. And if you don't know the vertex, then this equation's not very helpful. And this one right here, that's why I said it was hard. It's just hard because I'm feeling like I need some cookies, and so we don't know the vertex. We might be able to guess at the vertex and say that we think the vertex is at -1, and we might be right on that, and we might not be right on that. I don't think that we can automatically say that and then use it. And so we'll be able to know the vertex after we find the equation, though. So what we're going to have to use is we're going to have to use this one. And and we'll do that with each of the 3 points, not 2, 3. So x and y, right? And so, and I'm going to use that. So y, my equation builder is y equals ax squared plus bx plus c. So where I see y, I'm going to be putting in 2 equals a times x, right? And remember from yesterday, where I have x, I'm putting in parentheses here, plus c. This is just for people who sometimes get it wrong when they put in -2 here, and they don't say that this is 4. They say it's -4. So this is my first equation, 2 equals 4a minus 2b plus c. And I have 3 unknowns, a, b, and c. I'm going to try to find those unknowns by coming up. So this is my equation 1, and I'm going to come up with an equation 2. How I'm going to come up with equation 2 is I'm going to use x and y to be 0 and 1. That might actually be helpful. 1 equals, right, when I put in 0 there, a times 0 is 0, and b times 0 is 0. So actually 1 equals c. And so that's actually really helpful. And then that one was really helpful, wasn't it? And so equation 3, we have 1 and -2.5. So -2.5 is our y value. And 1 squared is 1, so this is pretty nice. So this is a plus, and then x times 1. 1 is x, so b plus c. But the good news is equation 2 tells us what c is. C is 1. So really, our equation 1 boils down. Oops, I didn't want an equals there. Our equation 1 boils down to 2 equals 4a minus 2b plus 1. And our equation 3 when I use the information that I'm given, boils down to 2.5 equals a plus b plus 1. And then I was going to talk to Tyler about why it's sometimes getting a little tiny bit out of focus. Tyler's my tech support here at the house, also known as my son. And so I have two tech supports actually. I think what I would do to solve this problem, you want to either, it's two equations, two unknowns. If you like, you can take the opportunity to put the 1 on the other side with both of these. So take away 1 both sides. And coincidentally, it's 1 here too. So that your equation 1 is going to now be 1 equals 4a minus 2b. And your equation 3 is going to be negative 3.5 equals a plus b. And then I think I would eliminate b. And in order to eliminate b, I need to make these be the coefficients be opposites of one another. And the coefficient of b right now is 1. And so if I multiplied equation 3 by 2, so 2 times negative 3.5 is negative 7. That's kind of nice. And 2 times 1a is 2a, plus, I don't have a pencil that's working very well, plus 2b here. And then the equation 1, I didn't do anything with it. So 1 equals 4a minus 2b. And one of the methods of solving a system of equations, two unknowns, is to make the coefficients opposite of one another and then add the two equations together. So if I do that, I get negative 6 equals, and see how that drops out the b's, that's why I wanted them to be opposite, 6a, and then all of a sudden we know that a is negative 1, right? So negative 1 equals a, so we're like hot diggity dog on that. And we can use the fact that a is 1 in order to get b, and we can go back to either equation 1 or equation 3 and find it. I'm going to choose equation 1 randomly, arbitrarily, because it doesn't have a decimal in it, whatever you want to say, doesn't matter. So 4 times a, remember now, is negative 1 minus 2b. And so in a matter of moments, I'm going to know what b is. So we're going to add 4 over here. So looks like b is going to be negative 5 over 2. So the equation of this parabola is y equals ax squared plus bx plus c. And y equals a was negative 1, so negative x squared, negative 1x squared, I don't have to write the 1, minus 5 over 2x plus c, which is 1. And so there we did a lovely job on that. I could now, by completing the square, if I wanted to, I could write it in vertex form. So this is vertex form if I wanted, so I'd have to complete the square to do that, because I'm kind of interested, you know, what was the vertex there, just because I'm curious. So one way to find the vertex would be to convert this by completing the square into vertex form. I think I don't want to do that because I'm feeling lazy. And so the shortcut for finding the vertex, so just because I'm curious, so this is because I'm curious, not because they asked me to find it, right? The vertex is the x-coordinate of the vertex. I'm going to put xc. X-coordinate of the vertex is given by negative b over 2a. And we know that a was negative 1. And we know that b was negative 5 halves. So the x-coordinate of the vertex is given by negative of negative 5 halves over 2 times negative 1. So when the dust clears here on that, I think that's at negative 5 over 4. And you could use your calculator on you if you wanted on that. And so here's my favorite calculator, the FX115. I love this calculator, the Casio. I also love this calculator here. It's the Casio FX991. And these calculators are about the same price, and you can get them at, places like Target and Walmart and Office Max and all those kind of places. I also have this calculator here, which is the Casio 300, and it doesn't have some buttons on it that I wish that it had, and it's a little bit cheaper, but it's a great calculator as well. Anyway. And if you're thinking, well, how many calculators do you have there, and do you have any TIs? And the answer is no. I have a whole bunch of Casios here ready to go because I love Casios. Casio should give me some kind of stipend or something. And I don't have any TIs. I wished I loved them, but I don't. Okay, so this is negative of negative, and then I have 5 halves, and I could put the fraction key again if I wanted, or I could have done it with division, and then divided by 2 times negative 1, and negative 5 over 4. So that's what I was thinking it was, but now I kind of verified it. That's the x-coordinate of the vertex, is x equals negative 5 over 4. And remember how when we were looking at the picture, and we were wondering, and I've had lots of students tell me that vertex is happening at x is negative 1. And I don't know, it kind of, did it look like it was? And now if I really get going on looking at here, this is negative 2. That line's not particularly straight, but this one. And so you can kind of see that no, it is not directly in the center between 0 and negative 2. And so it wasn't. It's a little closer to negative 2, which this number right here, negative 5/4, that's negative 1 1/4. And so, yeah, I can kind of see. Now, I could find the y-coordinate just by simply plugging in the negative 5/4 for x, and then I'd find the y-coordinate of the vertex. I was just curious about was it as simple as estimating that? And no, it wasn't. And so, oh man, we did a lovely job on that. And so, fortunately, we only have one more problem to do here. This is problem 17. It's about biologists have noticed that chirping rate of crickets of a certain species is related to the temperature, and the relationship appears to be nearly linear. A cricket produces 113 chirps per minute at 70 degrees Fahrenheit and 173 chirps per minute at 80 degrees Fahrenheit. And they want us to find a linear equation that models the temperature as a function of the number of chirps per minute. So basically, when they tell us this, they're wanting it to be the number of chirps to be x and the temperature to be the output. And so what they're saying is that, like, you go out to the woods and you're wanting to know what the temperature is, and you have these particular crickets. I don't know if the crickets at my house that were chirping like crazy when I was outside watering my garden last night are these particular crickets. And then you time them and count the chirps. And then you use our model that we're going to come up with to estimate the temperature. I'm going to have to try this tonight because I have a lot of crickets out there. And so we have then these two ordered pairs, 113 and 70, right? So that's the number of chirps and 70 degrees, and 173 and 80. And so if we were wanting to come up with the linear model that goes with that, then remember we had our equation builders, y equals, for linear, y equals mx plus b, and y minus y1 equals m times x minus y1. And those are the two that they use in our algebra. Oh, maybe the focus is because I've got this other paper that kind of goes up and down on there, maybe. And so it kind of just raises a little bit. And so do you notice that both of these equation builders, you need to know the slope, right? So no matter which one I'm going to use, I'm going to need to know the slope. And so since I have these 2 points, I can use the slope by using my famous slope formula, right, that you learned in an algebra class somewhere. So this is going to be 80 take away 70. And this is going to be 173 take away 113. So it looks like these crickets are pretty nice chirpers. So we have 10 in the top there. Do we have 60 in the bottom? Is that right? Am I doing if I'm doing my subtraction right? Because I'm at the point where all I'm thinking about is cookies. So we'll get going on at 60. So 1 over 6, right, is the slope. So 1 over 6 is the slope. And then if I wanted to come up, I probably would use this builder. You could use either one. You could use this and one of the points to find B and then come up with it. My algebra class always does this, so I'm going to use this Y1. I already labeled it. So 70 equals 1/6 times x minus 113. So y minus 70 equals 1/6 x. I don't think 6 goes into 113 evenly. I bet it does not, and it doesn't. So this is 113 over 6. Then I'm going to add 70 over there. So, and I'm going to run out of room. So I'm going to get y equals 1 over 6x. And then I'm going to use my calculator, negative 113 over 6 plus 70. So this is positive 307 over 6, which I could certainly write as a mixed number if you liked. The other thing is that they were telling me to, hey, use n and t, and I just went using the math and usually use x and y. So they really wanted t to be here and x to be in the number of chirps on a cricket chirping away. And this is going to estimate the temperature. So if we count how many chirps in a minute, then we'll be able to estimate the temperature. They ask us, what is the slope of the graph and what does it represent? So the slope of the graph, it's kind of silly because we found it, right? But the slope of the graph is 1 over 6, and I think what they were really wanting to know is what does it represent? Now the numerator up here on the slope is temperature, is what it is, and that was in degrees Fahrenheit, right? And the denominator, the x's, are the chirps, and so this is the number of chirps. And really, the crickets aren't changing the temperature, and but they're predicting the temperature, right? And so this is a prediction. So as the number of chirps, for every 6 chirps of increase, the prediction of the temperature goes up 1 degree. So I could say that for every increase of 6 chirps off the crickets, the predicted temperature increases 1 degree Fahrenheit, something along those lines, right? So that's what it's telling us about cricket chirping. If the crickets are chirping at 150 chirps per minute, estimate the temperature. So we can put that in to our formula here. T equals 1/6 multiplied by 150 chirps plus 307 over 6. And so this is going to give us, I am definitely going to go out there and see if I can count. I don't know how easy it would be to measure cricket chirping. So I just decided to put it in my calculator. And I used the fraction key here for the 1/6 and chose not to use it for the 307 divided by 6. I could have done it though. If I would have wanted, I could have used that fraction key, right? 307 over 6. And so I get this crazy value, which doesn't really make sense. I mean, like if someone told me this was the temperature in degrees Fahrenheit or the predicted temperature in degrees Fahrenheit, I'd be like, what the heck? So I'm going to convert that into, and I chose to convert it into a mixed number, but you might have chose to convert it to a decimal. That key right there, S to D, says standard to decimal, and behind it, it does to mixed number. So if I go shift here, it converts it to a mixed number. So either way, and so, and chirpers, crickets are probably not extremely accurate at predicting the degrees Fahrenheit. So I'm just going to say 76 is what I'm thinking. The temperature is around 76 degrees Fahrenheit. And so kind of warm out there. I know what you're thinking. How can you say that's kind of warm? 105 is kind of warm, right, for us. Okay, so that's section 1.2.